let's proceed from where I had left. So I'm saying number one, the layers or the hexagonal plates in graphite can slide over each other because of these weak van der Waals forces of attraction. And in that case, it makes graphite a very soft and slippery substance. Look at grease. Grease is a very good example of graphite. Just put some amount of grease between your fingers. Slide your fingers over each other. You can feel now the softness and the slipperiness of whatever I'm trying to talk about. So it is soft and slippery because of the layers sliding over each other, because they are held together by weak intermolecular forces of attraction. The second physical property of graphite is that it is insoluble in water. Why? Because I've told you graphite is actually a non-polar substance and water is a polar solvent. So polar solvents are the only ones that can dissolve in polar substances, and non-polar solvents can only dissolve non-polar substances. And graphite being non-polar, it makes it very impossible for it to dissolve in a polar solvent, which is water. So water is a polar solvent because it's partially positive and partially negative. Graphite is non-polar, not partially positive and partially negative, so it cannot dissolve in water, but it can dissolve in non-polar solvents like carbon 4, sulfide, and methyl benzene. Number 3, you should also note that graphite is smooth. I've already mentioned that one. It's smooth, soft, and slippery because of the layer sliding over each other. So it has what we call a soapy feeling. You see, it has what we call a soapy feeling when it actually gets touched or felt between fingers. And it also has what we call a greasy touch. You see, a greasy touch. A greasy touch, a soapy touch. It is soft and slippery and smooth. And this graphite also has high melting point and boiling point. Why? Because between the carbon atoms you have what we call very strong covalent bonds of attraction. That makes it require very high temperatures for those strong bonds of attraction to be broken. Correct. So again, you can also talk about electrical conductivity. It's a good conductor of electricity and the only non-metal in the whole world in as far as electrical conductivity is concerned, because it does not use all its 4 valence electrons in bonding. It uses 3 electrons, so it has what we call one delocalized or mobile electron. That's what it uses in conducting electricity. So it's a good conductor of electricity. So it's a good thermal and electrical conductor because it has one delocalized electron. Now, scientists have actually been saying that graphite is actually less abundant in the environment. So what happens for us to have more of the graphite? You'll find that they'll actually be able to have coke getting obtained from coal. So if this is the coal that is actually a mineral, it gets mined. They actually heat this coal in the inadequate supply of air to around 1200 degrees Celsius. They obtain coke. The coke also undergoes heating. You see, it gets subjected to very high temperatures and pressure now to obtain graphite. The coal gets mined. It gets subjected to very high temperatures in the absence of air to a temperature of 1200 degrees Celsius. The coke gets obtained. The coke gets subjected to very high temperatures and pressure. The graphite gets obtained. So you can be able to manufacture graphite as easy as that. Yeah, I think those are some of the physical properties. And of course, graphite is black and opaque, you see. So it is actually easy for you to come up with such factors just in case they get asked in the examination. And in that case, I can go to the uses of graphite. Number 1, graphite is used as a lubricant. Why? Because it has what we call the intermolecular forces of attraction, which are weak between the layers of the hexagonal plates. So the plates or the layers slide over each other, it becomes slippery. So it gets used as a lubricant since it can reduce friction. Number 1, it can be able to actually reduce the effects of rusting in as far as iron is concerned. And again, it can be able to actually get to that point of increasing the luster of whatever gets lubricated. Yeah, so it's actually used in engine parts to reduce friction as a lubricant. Good. And again, it is actually used so as a lubricant. That is number one. Number two, it is actually used as an electrode. Why? It's actually the only non-metal that can conduct electricity. So it is used in making electrodes in batteries and cells, you see, because it's a good conductor of electricity. So the black substance that actually gets found in the middle of a dry cell is actually graphite. So it's the electrode of that dry cell, and the reason as to why we are using that to make those electrodes because it's a good conductor of electricity. Graphite is actually used as a moderator in nuclear reactors where the temperatures are very high. So it has the highest ability of absorbing heat. So the excess heat that actually comes out as far as the reactions in the nuclear reactors is concerned will get absorbed by graphite. So because it's a good conductor of heat and electricity. So that is why it's actually used in nuclear reactors as a moderator because of its ability to absorb the excess heat. Graphite also gets used in actually making what you call pencil leads because the layers slide over each other, so the writing becomes very easy. The layers of graphite at the end tip of that pencil can slide over each other and the writing can get done in an easier way. So making pencil leads, making pencil leads, making pencil leads. That is a simple summary that I can give in as far as the uses of graphite are concerned. As far as the uses of graphite are concerned. The uses are so many, you can be able to get others in other applications, either in the medical field or any other area, but please just take note of that one. It's something very, very important. So I had actually mentioned something on Fullerene, and I told you Fullerene is actually a complex structure that can have to a minimum 60 carbon atoms. There are rare cases of where carbon can be able to exist in this state and be able to have around 72 carbon atoms, 80 something carbon atoms, but the major one, as far as Fullerene is concerned, has 60 carbon atoms. So the 60 carbon atoms are the ones that actually make the structure to be very complex. It's actually able to look like buckyballs, you see. Buckyballs, you see. Buckyballs. So that just gives a simple structure of Fullerene, 60 carbon atoms, you see. It looks like a buckyball made up of many carbon atoms. This has quite a good number of applications, like it's used as an absorbent in gas masks. It's actually used in biomedical fields, you see, and its application is actually relevantly important as far as our living is concerned. And that's why its discussion as far as chemistry is concerned is very, very important. So Fullerene as an absorbent in gas masks, used in biomedical fields, used as a lubricant, and many other applications. Okay, so those are the crystalline or pure forms of carbon. We may also want to look at what we call the amorphous or the non-crystalline or the irregular forms of carbon. I've mentioned something like coke. Coke is the first form in which carbon can exist in as far as non-crystalline state is concerned. I've told you how do we make coke. We mine first coal. See, so coal can be the first form of carbon in as far as its amorphous state is concerned. Coal is a mineral. It gets mined from the ground, and in this case is actually able to now give us what we call coke if it gets exposed to very high temperatures in the inadequate supply of air. Coke gets given. Remember, when coal is heated to a very high temperature, in this case in the inadequate supply of oxygen or air as the main active part of air that supports combustion, then it means that now it can be able to give us coke. It can give us also coal gas. It can give us also coal tar and even ammonia gas, which is what we call a choking and irritating smell. So when coal gets heated to this temperature in the inadequate supply of air, it gives us coke, it gives us coal gas, it gives us coal tar, it can give us ammonia as well. These are all used as fuels as far as our heating or cooking in our domestic purposes are concerned. And you see, in this case, that actually just discusses two main amorphous forms of carbon. We have what you call lamp black. Lamp black is actually able to get formed, and it gets formed when fuels are burnt in the inadequate supply of oxygen. Fuels like diesel, petrol, or gasoline as well, or kerosene or paraffin, that is just a jet fuel. We have also what you call the lubricating oil, we have what you call the fuel oils, and even bitumen that is actually used in road tarmacking. Bitumen or asphalt or residue used in road tarmacking. So those are just examples of fuels that get obtained from crude oil through what we call fractional distillation. So when they get burned, they undergo combustion in the inadequate supply of air to produce lamp black, which is now an amorphous form of carbon. We have what we call wood charcoal. It gets produced when wood gets burned. Remember, wood is actually containing carbon, because when plants manufacture food in the presence of sunlight and carbon dioxide through photosynthesis, the carbon forms part of the food that gets manufactured in as far as the structure of starch or glucose is concerned. And in this case, if plants make their own food, they'll use what you call photosynthesis as a process. They'll have to have carbon dioxide, they'll have to have water, they'll have to have light, and of course photosynthetic enzymes that speed up the rate of the reaction. So in this case, we obviously have to expect a very simple structure of glucose as C6H12O6. So the carbon is present. This forms part of the structure of the plants. When the plants get heated, as far as their parts are concerned, the wood gets charred. It produces what we call wood charcoal. And we also even have what we call animal charcoal. Now look at this. Animals are actually heterotrophic. They depend on what the plants have manufactured, and that is actually to say, if plants manufacture glucose, they may store the excess glucose in form of starch. The starch is stored in the plants like in maize. The maize gets eaten by animals. That means now there is carbon in this starch coming from the excess carbon that is found in the glucose. And in this case, when the maize gets eaten, which is actually starch containing many molecules of glucose, the carbon in the glucose forming now the starch will get broken down through the inadequate heating, the inadequate supply of air, to form again what we call animal charcoal. So this is where the bones get burnt and they produce what we call animal charcoal. So that's what we call animal charcoal. So the animal bones and the remains of animals get burned to produce animal charcoal, especially in the inadequate supply of air. You see, charcoal is extremely porous, you see, and a small piece of charcoal will have a very large surface area, for your information. And if it has a large surface area to volume ratio, it is very important in absorbing molecules of other substances on its surface. So for example, you can use animal charcoal in the sugar industries to absorb impurities from brown sugar before crystallization is done to give this sugar the white appearance. So animal charcoal is used in sugar industries to absorb impurities from brown sugar to give the sugar its white appearance. So charcoal can also be used to absorb gas molecules and is often used to remove the last traces of a gas in a high vacuum work. For example, let's say you are actually in an industry where very poisonous gases are actually produced. In this case, the gases are actually able to give us what we call a white or an impure form. So in that case, we may want to use this charcoal to actually remove the impurities so that you don't allow these impurities to exit into the atmosphere to cause pollution.